Hello everyone. This video will show how to transform a general function of the form y equals af quantity bx minus h plus k. To better understand this, let's have an example. In this problem, we're supposed to sketch the graph of y equals f of x minus 1. So this given graph that we have here is our parent graph. We can actually rewrite this given equation right here as y equals f of x minus, that's actually a positive 1. So that's how it came out to be x minus 1. So this tells us that our h here is positive 1. And our k here is 0. So it's just like plus 0 and plus 0. So our k here is 0. Now we remember that the parameter h translates the graph left or right. Since this is a positive 1, it translates the graph to the right. And since this is 0, it does not move either up or down. So I'm just going to go ahead and write that up here. To sketch the translated graph, we can go ahead and write the vertices of the graph. So the translated graph here would be, for each of the vertices here, we're moving it 1 unit to the right. So this one is going to go right 1 unit. This one as well is going to go right 1 unit. This one is going to go right 1 unit. This one is going to go right 1 unit right here. And this one is going to go 1 unit to the right. And then we can sketch the graph. So this is the graph of y equals f of x minus 1. Now let's have another example. Okay, let's go over this example. So this equation that we have right here can be written as y equals f of x minus 0, or you can have plus 0 and then plus 4. This tells us that our h is 0 and our k is 4. This means that the graph is not moving left or right, but it has moved up 4 units, because since the k is positive, so that it means that it went up 4 units. So we can go ahead and sketch the graph here. So the first thing that we need to do is to put the vertices of the parent graph. Now we're going to translate each of these vertices 4 units up. So that would be 1, 2, 3, 4. Then that's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And we will sketch the graph. So this red graph right here is y equals f of x plus 4. Now let's have another example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over this problem here. So this given equation that we have here can be rewritten as, so this plus right here is actually a minus and a minus, which tells us that our h is negative 2 and our k is negative 4. Since this is negative, it went to the left 2 units. And since this is negative 4, it is translated down 4 units. So I'm going to go ahead and write the vertices for this graph. Okay, so what we're going to do here is that we're going to translate the graph 2 units left and 4 units down. So that's going to be, for this dot here, that's going to be 1, 2, 1, 2, 3, 4. So this is the position of this dot. Next dot right here, 2 left, 4 down. 1, 2, 1, 2, 3, 4. This next dot right here, that would be 1, 2, 1, 2, 3, 4. This next dot here is gonna go 1, 2, 1, 2, 3, 4. And this last dot here, that's gonna be 1, 2, 1, 2, 3, 4. And then I'm gonna go ahead and connect the dots together. So this is the graph of y equals f of x plus 2 minus 4. Did you get the same answer as this? Good. Perfect. So that is how we apply transformation to general functions.